Welcome to Nuclear Energy in Korea, a podcast to promote discussion of major issues and challenges in U.S. and Korean nuclear energy. I'm Alan Ahn, and I'll be your host today. We have the great honor of speaking with Mr. Nobuo Tanaka, former Executive Director of the International Energy Agency, or IEA, Global Associate for Energy Security and Sustainability at the Institute of Energy Economics, Japan. He is also professor at the Graduate School of Public Policy in the University of Tokyo. Mr. Tanaka, thank you for taking time out of your busy schedule to speak with us.
Yeah, you are most welcome, Alan.
So my first question would be, you were executive director for the IEA back in 2007 to 2011. Although it's only been several years since you left the IEA, many basic assumptions about the IEA's core issues, such as energy security, oil security, and so forth, have dramatically changed. Is the world more or less complicated for the IEA compared to when you were the executive director?
Well, that's a very interesting question. I think the world is getting always more complex with new issues, and many of the, let's say, changes have happened since I left. One is geopolitical instability is very, very high. The Middle East situation with Islamic State in Iraq and Syria is enormous. It has unfortunately just recently Japanese hostages were killed, and there's a strong concern about the security of the people. But the energy market is the same thing. We have serious uncertainty there, and unfortunately it's not decreasing. So we have to prepare for the unfair, let's say, instability or things, very difficult situation or emergency may happen. So this instability or the kind of, let's say, volatility in the market is probably getting worse. This not only geopolitical, another geopolitical issue is the Ukraine and Russia. This Eastern European situation is getting very, very difficult, and we haven't seen no exit so far. And sanctions by the U.S. or G7 countries is creating economic impact to Europe as well as, of course, to Russia. So how this goes will have a significant impact to the energy market. Where Russia is certainly the very big supplier of oil, gas, and coal. So how the investments there, Middle East or anywhere, may have the impact to the future market. The current low price was triggered by the OPEC decision to maintain the production of oil, and this gives the very strong shock to the market, and oil price is getting lower and lower these weeks and months. So this is a challenge to the very high cost producer, the shale, the oil of the North America. So we know that the shale revolution changed dramatically the oil and gas market so far, but now the new challenge is how the investment to these unconventional oil and gas continue. And this has significant impact to the future demand and supply. So, in a way, OPEC or Saudi Arabia is testing the resilience of these shale oil and gas. So these are the very big uncertainty to the market in the future. So the IEA has long been concerned, and still it is valid, is that the long-term capacity or supply capacity of oil and gas certainly, demand side is getting stronger and stronger from emerging economies like China may stagnate to some extent, but India will continue, or ASEAN countries, Africa is coming, Latin America. So the emerging market demand for energy will continue to be very strong. So supply side, if there is not enough investment, so the problem will come back again as short supply vis-a-vis very strongly growing demand. So this kind of situation is very easy to imagine. So IEA has always continued to warn the market that we have to think in the longer term and maintain the certain level of investment for the future security. So, well, the situation is, in a way, not changing, but challenge to the stability or security is definitely rising. That is my view. Yep.
You briefly mentioned the shale gas revolution going on in the U.S., and according to certain projections, the U.S. will become the largest producer of gas and oil in the world. To what extent can the U.S.'s newfound energy independence and energy surplus help mitigate energy security in other parts of the world, such as Europe or East Asia?
Yeah, certainly this unconventional energy source for gas and oil in North America and its technology of this shale development, so-called horizontal drilling as well as hydrofracturing, certainly open the huge potential for other countries also, like China or Argentina or Canada or even Middle East and some part of Europe. There are huge potential of shale development. So this will give the new age of unconventional gas and oil. Of course, in a relatively shorter time, if the United States has ample supply of gas and if it is going to be liquefied and exported to Asia, where the demand grows in a very fast speed, Japan or China or Korea or ASEAN countries, certainly this American export will help the Asian economic growth in a sustainable manner. The gas is definitely cleaner than coal and definitely cheaper than oil. So the gas is a very important source of energy, and of course there are some caveats about sustainable production methodology or containing the leakage of gas or methane or etc. But if we satisfy these conditions, which IEA called them as the golden rules, then the golden age of gas is coming. And I think this situation is continuing, and this will certainly help to enhance security and sustainability in the United States, but also it helps to some extent those countries using gas for the future fuels of the economic growth.
Switching gears just a bit, how important do you think nuclear power is for international energy security and sustainability? Do you believe you need a global nuclear renaissance to have meaningful carbon mitigation and an energy secure world? Or do you believe there are any possible alternate scenarios without nuclear?
This is an interesting question, very important question. And certainly after, unfortunately, that unfortunate accident in Fukushima, there are certain concerns about the safety of the nuclear power, especially in Japan, but not only in Japan, in many countries. The safety is the issue number one. So we can see the recent World Energy Outlook, which IEA has released last November, and there's a special chapter on nuclear power. And IEA says that nuclear will still continue, even after Fukushima accident, to grow by about 60% from now to 2040. So especially in the developing countries like China, India, Russia, East Asia or Southeast Asia, so it is quite clear that emerging economies or developing economies need a very stable supply of electricity through nuclear power. So, but to make the public acceptance more available in many countries, IEA says that we have to prepare for the safety standards. International safety standards must be abided by many countries, and the public must understand how the countries deal with the issue of decommissioning of the older reactors, because IEA says about 40% of the old light water reactor system must be decommissioned by 2040 in the world. So how to replace them or how to decommission them is certainly the very important issue for the public acceptance. Another one is that the spent fuel, or how to deal with spent fuel or high-level waste if some country do the reprocessing. The IEA says currently there are about 350,000 tons of million tons. Excuse me, just check million tons, I guess, of waste, and 1,000 tons. Excuse me, 350,000 tons of waste, and it will expand to by double, 700,000 tons in 2040. So how to deal with this spent fuel is certainly another very important issue for the public acceptance. So try to find these requirements of safety or issues or decommissioning, spent fuel, the waste, radioactive waste, or maybe the issue of nuclear non-proliferation is another important element that the nuclear community must to address. And then this will help much better understanding of the public and will give chance of promoting of nuclear. And IEA also analyze if nuclear power is not taken as an option, that certainly the global community suffer with higher CO2 emission, as well as lower energy security for certain countries like Japan or like Korea, where we need much more exogenous sources of energy. So I also calculated if low nuclear case, like zero nuclear in Japan, gives a very strong detriment for the Japanese energy security as well as sustainability of showing clearly that how much more CO2 emission happens or how much more money Japan should spend on buying more gas and oil. And so these are the definite, let's say, impact of not operating nuclear power. We are wasting, Japan is wasting 4 trillion yen, $40 billion of additional purchase of gas and oil every year. And this is not sustainable. So I strongly believe that nuclear power is a very important source for energy security as well as sustainability. Of course, we should not forget about other tools of sustainability like renewable energy. So we need to have a very good design of the energy market, or strong connectivity of the grid lines, or a very reasonable system of feed-in tariffs or support measures. These are the necessary conditions to have more renewables, and also continue to have the efforts of energy efficiency, etc. So all these efforts must continue, but at the same time, nuclear still continue to be a very important option, which we should maintain for the future.
So the U.S. is still the world's largest producer of nuclear electricity? nuclear electricity, but the U.S. nuclear industry has faced some fairly heavy financial pressures as a result of cheap natural gas, and the struggle now seems to just maintain the existing fleet in the U.S. for as long as possible, given that the pace of new build in the U.S. is rather slow. You are obviously a believer in nuclear power and you support it. Given the current trend or the trajectory of the U.S. nuclear industry, what would your advice be to U.S. policymakers and leaders?
I see. Yes, that's a very, very important point. I think the United States has long been a leader of the nuclear power in a military way or in a civil use. So I think the United States should continue to be a global leader in the nuclear technology. The United States is very lucky with shale revolution. The very cheap gas gives a strong advantage of using gas and shifting from coal. So by moving more from coal to gas, as well as using more renewables and efficiency measures, the United States has successfully reduced CO2 emission and enhanced energy security as well as economic growth. So through this shale revolution, the United States achieved win-win-win situation, triple win situation. It is very lucky because thanks to the shale revolution, but this will not continue forever. The shale is not forever. Oil especially will come to the peak in a decade or so, and slight will reduce the growth gradually, and gas will continue to stay, but it's also cannot be forever. And the United States must think about where the U.S. Must move into in the future. Especially, I must clearly show the risk of losing the nuclear leadership of the United States, because there are lots of competitors in the world who are going to use nuclear power, like China or India or Russia, and they are thinking very seriously about their technologies be exported to other developing countries. So if U.S. is losing its market in the future, certainly security as well as non-proliferation risk may grow. Another big concern for me is the situation in Japan, and in a way, to some extent, related to Korea. These two U.S. allies have some problem for the future nuclear power. Japanese case is typical after Fukushima. There is such a strong public concern about the safety and the nuclear power. So the discussion about what we should do the nuclear in the future is very much fragile. And also, for the sake of safety, for the sake of proliferation, for the sake of waste or spectrum management, I think these issues must be addressed clearly for the future. Korea certainly needs nuclear power and pyroprocessing or new reprocessing mechanisms to deal with their spent fuel. So we know that the 123 agreement revision is moving on. To have these two countries, and Japan is also facing the 123 agreement revision in 2018. So these two countries, as a very strong ally of the United States in the nuclear power, we have to cooperate to save the future of the nuclear together. And I think the very important technology has developed in the U.S., so we have to continue work on that in that direction and recover the credibility and the public trust of the nuclear power. I think the United States leaders and politicians or political leaders or policymakers should understand the current nuclear situation well and prepare for that direction. That is my strong conviction.
Mr. Tanaka, you have often stated that a crisis such as the blockage of the Strait of Hormuz, disrupting oil and gas supplies from the Middle East, would put Japan into a quote-unquote economic death spiral, especially with no Japanese nuclear plants in operation. Let's imagine the reverse scenario. Would an energy crisis, one that results in an economic crisis, convince the public, the stakeholders, and the government in Japan to push for nuclear restarts?
Yeah, that's a very good question and very legitimate, let's say, concern. Once this blockage of Hormuz happens, Japan lose 85% of oil and about 30% of the gas. And some part of Japan will suffer much more than other parts because they depend on the import from gas from Qatar, import of gas from Qatar. So tube electric, especially in the center of Japan, will have a huge blackout if the Hormuz Strait is being blocked. So I think this will happen at any time. The problem is that Japan is not really prepared for that. No way to prepare. Well, this is a nightmaric scenario for them. IA executive director, so we are always preparing for the situation like that. But it is very difficult to really cope with if something, that kind of thing happens. Oil, we still have quite a big, strategic stockpile, but it's also the matter of 100 days. It's Japan has about 180 days of stock, but it's still just 6 months. So, the risk of Middle East, especially the Strait of Hormuz, must be prepared. So I'm asking the question like, if no nuclear power is running in Japan, and if this kind of unprepared situation happens with Strait of Hormuz, what would be the consequence? So this is very, very serious situation. And I warn the policymakers here in Japan that this could happen much more frequent than once in 1,000 years, like tsunami. It could happen every 50 years. So we have to prepare the scenario for that and make sure that if something this happens, we have something, some measures to deal with. And restarting nuclear power is a very good example. But the current rules of the restarting of the nuclear power, we need very stringent screening of safety standards of the newly created regulatory agency, and there's no emergence measures of restarting without such kind of process or alternative process, for example. So I'm a strong advocate of we need to prepare that kind of situation. And there are other possible natural disasters as well. So this kind of preparedness is certainly very important, and I think public will notice right away if the blockage of Hormuz happens, but the cost of unpreparedness is enormous. So my point is, yes, this sounds like a scare story to the public, but policymakers must always make a good scenario for that and prepare enough. And I don't hope that this situation happens, and that is causing, let's say, public acceptance back to the nuclear power. The cost is in such kind of situation is going to be too high.
So as you say, being prepared and having a diversity of energy sources such as nuclear, that's probably the main way to enhance energy security for a country like Japan. You've also
Exactly.
talked extensively about the role of technology in strengthening energy security, for example, changing the way energy is delivered and used, making available previously inaccessible sources of energy. What technologies and development do you believe can have the greatest impact or the most immediate impact?
Technologies, there are many possible different kinds of technologies to enhance energy security. Of course, nuclear is one, but other than nuclear, there are plenty of methane hydrate or gas hydrate surrounding Japan in the bottom of the ocean. And this methane hydrate has already been proven, but still we need technologies to recover and use it in a commercial gas supply. Japanese government is very strongly committed to the technologies of getting gas hydrate from ocean. And it succeeded for the very short period 2 years ago that this is possible. So they continue to develop and test the commercial viability as well as the environmental impact studies, and the time will come when the gas price or oil price may reach to the very high, and then the gas hydrate is getting more competitive. That is another, this is the hydrocarbon, but certainly this is one way to enhance security. Another technology is storage of electricity. There are many different ways, batteries, different type of batteries, or hydro pump-up stations, etc. But probably hydrogen is a very strong way of storing energy or electricity. Japan the Toyota has started hydrogen fuel cell vehicle, and hydrogen stations, pumping stations are being deployed. And storage or transportation technology could be developed much more seriously. The Toyota engineering is doing chemical hydrate method. Kawasaki Heavy Industries is trying to transport it by freezing or let's say liquefying the hydrogen. So if these technologies is getting available, so then storing excess electricity by the renewables like wind could be transformed into the hydrogen and stored for the use of thermal energy. So this is a kind of futuristic, but just importing LNG will not increase value, but this hydrogen will increase value by removing CO2 emission, means exporting or trading cleaner fuels is certainly the value added when the price of carbon is getting higher. So this is another technology. Of course, other smart grid-related technology could be deployed, managing the demand side or even coordinating supply side with storage technologies. So this kind of grid-related technologies certainly help. So all these technologies, including nuclear technology, for the future will enhance energy security.
Okay. So you just discussed a number of non-nuclear technologies. The nuclear technology, the nuclear power technology that you have been an outspoken supporter for, and you touched upon this a bit earlier, is the integral fast reactor, or IFR.
Right.
And I believe you may have hinted at this earlier, discussing spent fuel issues, safety, and public acceptance. But what are your specific reasons for promoting the IFR?
Okay, well, that is another next very important subject of my comments. I strongly believe the integral fast reactor or GE's PRISM reactor, a modular type of IFR, may help to regain the public acceptance in Japan, because IFR has been experimented in the United States in 1986 at the Argonne National Laboratory for its passive safety feature. Yes. By giving, just like Fukushima accident type simulation or experiment, cutting the total power supply to the reactor, and it stopped automatically. So it has a technical feature of passive safety, and that is proven. And I saw the movie Pandora's Promise and very impressed with the fact that this reactor has been developed in the U.S. and it is tested as such. So why I was working for METI, Ministry of Economy, Trade and Industry, and even did some part of the nuclear work there, but I didn't know this technology until recently. And Japan took different option of reprocessing by the Purex method, as well as Monju, the breeder reactor technology, as a fuel cycle option. This IFR of the Argonne National Laboratory could be a very important alternative for the fuel cycle option. Also, I learned that IFR and pyroprocessing, which is combined reprocessing technology for the metal fuel, is certainly technically much more proliferation resistant. And this is another very important feature for the developing economy, if any, to do the civil nuclear power in the future. And third, but the most important, is how to deal with the waste or spent fuel from the reactor. And this technology certainly reduces substantially the radioactive or toxicity of the high-level waste, and it doesn't have any spent fuel because it automatically reprocess the spent fuel into the fuel for the reactor again. This closed circuit is very promising for the waste management, and the toxicity of the final waste is just 300 years. And when we compare it to the current light water reactor systems, 100,000 years, certainly this is significant difference of the ease of waste management. So with these 3 points, the passive safety, non-proliferation, and easy waste management answers the challenges of the nuclear power after Fukushima. So I think IFR or PRISM model may provide the so-called sustainable path or sustainable development of the nuclear power. So, and I'm testing this technology as a possible solution for the Fukushima Daiichi catastrophe, because there are huge debris of spent fuel which melt down in the first, second, and third unit. So TEPCO will take out this meltdown debris, but the technology to deal with this debris, I think pyroprocessing is considered to be the best technology to separate the plutonium, the fuels to burn from the radioactive waste. And radioactive waste must be dealt in the Fukushima prefecture. So I'm now proposing that this prism or pyroprocessing must be tested or demonstrated in the Fukushima, and especially Fukushima Daini, the second Fukushima reactor site of the TEPCO, is probably the best place to do that. So for Japan, I think we need urgently to try this technology and prove that this is very viable option for the future deployment of the nuclear power. Here comes a very interesting issue that U.S. and Korea are now testing and working on this pyroprocessing together. So I'm saying that maybe the triangular cooperation between Korea, Japan, the United States in Fukushima as a new test bed for this IFR as well as pyroprocessing may provide a very interesting impact or input to the work of the integral fast reactor. Well, I don't know if this goes, but I'm talking publicly of this idea. Just recently, I was invited to the Liberal Democratic Party's very important nuclear power council or framework, the committee, to discuss about the future of the nuclear, and expressed and explained this proposal. And I think they very well understand the possibility. So this is not easy, but I think IFR and pyroprocessing is very important alternative, and increasing the options which may complement the current light water reactor system.
So you have proposed this idea of a joint trilateral fast reactor development partnership among Korea, the U.S., Japan, at many different forums, different audiences, including our roundtable, Global American Business Institute roundtable back in September of 2014.
Exactly.
And you've had this idea of testing this idea and getting feedback, responses. What have been the most valuable or important lessons, feedback that you've received from these various communities or people that you've proposed this idea to?
Well, of course, the first reaction from the people I talk to, the general public or experts, is, wow, I haven't heard about it, this technology. So the awareness of the technology is not enough. And my current activity of mine is to increase awareness of the public about this technology. Even I tried this in Fukushima Prefecture. I explained the possibility, and the lady who listened to my speech came after and, wow, Mr. Tanaka, I have never heard about this technology. Why we were not being informed about this? So sadly, the nuclear community here is very cautious about saying some new technologies about nuclear. And fast reactor is always considered as a kind of dream technology, but not really happening except in a very experimental manner in some countries. So, and unfortunately, because of Monju of the fast breeder reactor in Japan lost public confidence, Rokkasho reprocessing plant hasn't been really coming to the operation. So some suspicion, very strong suspicion about the fuel cycle technology exists here. So the nuclear community or policy makers or politicians are very cautious of presenting some new technologies. But I think because we are not doing that, the public are not really aware of the situation and making very, let's say, emotional decision eventually. So this is a risk. So I'm saying, and also when I talk to the nuclear professionals, including not only in Japan but U.S. and Korea, well, there are many people who think this is a very important and possible option. So I'm very much convinced that now this is a time to test the public, how they think about this technology as a sustainable nuclear power, as a concept of sustainable nuclear power. It is a closed circuit technology, and responding to these difficult questions which were not really addressed by the current technology. The light water reactor paradigm is quite obvious. The military application, the power reactor for the submarine, or enrichment for making the uranium bomb, or reprocessing Purex methodology to produce plutonium for bomb. So unfortunately, these light water related, reactor related technologies are very much proliferation prone. So, of course, for that sake, United States experts very much carefully treat this technology for safety and proliferation risk, while not directly responding to the disposal issue. It's temporary solution is just keeping spent cell in the dry cask at the plant site, and this is U.S. has luxury of doing so with full of space, as well as shale revolution resources with coal also. So U.S. is very much of has a luxury not to think seriously about the future of the nuclear power. But it is not permitted for Japan as well as Korea. We must be seriously think about the more complete set of the nuclear technology as a sustainable nuclear technology. And I think this IFR and pyroprocessing, probably, as far as I'm not an engineer or scientist, so I can not really prove myself for its technical viability, but it seems to me when I talk to all the professionals who are dealing with this technology, it seems to me that it provides a huge potential for the future energy, for future nuclear or future energy option. So we'll see. I'm working in Columbia University and writing the paper, and in April we are hosting one conference in April, and releasing the paper as well as promoting these concepts in the United States, because certainly, as I said, the United States is technology leader and who developed this IFR in the Argonne National Laboratory. I think U.S. is in the best position to restart this nuclear technology. It's also always unfortunate. It is very unfortunate that nuclear issue is treated as a political agenda. And if the government changes, sometimes nuclear is considered very positively. When the government change, it is considered the other way around. So the change of government policy on and off and on and off will send a very bad signal for the private sector to invest. And the IEA, the International Energy Agency, always warned the governments not to change energy policy frequently, because energy infrastructure, they very, very long time period and a huge initial investment needed. So the private sector cannot really invest if government policy change from time to time. So I think to make secured energy future and sustainable energy future, I think this is a very important time that we have to come up with the clear direction and the technology option, and show the public we are very much committed to that direction.
Mr. Tanaka, thank you for sharing with us your very valuable time, and thank you so much for your candid and interesting thoughts on energy and nuclear power and of course the IFR. So thank you so much for speaking with us today.
You're most welcome.